Okay, so Jonathan, so if you come right here into the search bar next to the Windows icon and you start typing snipping, it's gonna show up. Like this is the snipping tool, right?
Mhm.
And you open it up, and if you click on new, it's gonna open this. Say you did some work and you want to take a picture of what you did. Let's say I want to take a picture of this space.
Mhm.
You just use the plus sign on the snipping tool.
Mhm.
You click down on your mouse and just do this. Like if I do this right now and then I let go, it's gonna take a picture of that.
Okay.
And then I can save this and attach it to my homework.
Mhm. Okay.
Or you can just drag this image and just put it in your homework.
Okay.
Yeah, so that's how it works.
All right. Thank you.
Welcome. Okay, so I'll stop sharing. And before I invite Professor Charles to take over the class, so Charles is going to take over the class today, tomorrow, and all next week. So the next 2 weeks are going to be intensive networking, right? And after that, after we're done with networking, Kingsley is going to come back and he's going to finish up Windows with Active Directory, group policy, and domains and domain controls. And after that, we'll be all done with the first part of the course. And I think first week of March, oh, sorry, first week of April. I think we're already in March, right? First week of April, we'll be starting Linux. So, so that's the plan. So everything we did last week in terms of me introducing you to networking, I don't know if you guys had the opportunity to watch the class on Saturday. I was trying to use some diagrams to explain to you how local area networks are actually designed, how they work, So everything I've explained to you from last week is just a teaser. It's just like a build up to what Charles got for you. At least I've introduced you to IP addresses, local area networks, LAN WANs, metropolitan area networks, routers, switches, and all that. So you guys have an idea of what all those things are. And when you guys go through through the homework, you guys gonna learn more about networking. But from today, like I said, Kingsley is gonna be our network expert, and all network related questions, you can send them to me or you can Slack them directly to him. And I hope you guys are gonna have fun. Bombard him with questions. He's very smart, but you guys should challenge him, and we're gonna have fun with him. So, Charles, you do have a co-host. Uh, I just made you the co-host, so you are in control, and let's have fun together.
Hey guys, how you guys doing today? Can you guys hear me?
Yes, sir. I can hear you.
Oh, all right. I thought I was talking to myself. All right, today I'm in the office. That's where I'm working from, because I can't concentrate when I'm at home. I'm just adjusting something here because I just realized my computer is a bit low, so I just want to adjust it so it's a bit higher, so you guys can see my face as I talk to you guys. Okay, that should be better. All right. First things first, I think we're going to do some housekeeping. I just got a message from Gerard during the week because we get to talk a lot, especially sometimes when we're troubleshooting issues. and you told me you guys are not doing your homeworks. I was just like, really? These guys are just doing definitions of terms, networking terms, and they're not submitting their homeworks.
I think for the most part, everybody did. I'm still missing homework from Ebenezer, and I've even sent him a message on Slack. He's not responding. So Ebenezer, I don't know what's going on, but please send in your homework. I don't know why you're not responding to my messages. So you are the only one missing homework right now.
Yeah, so guys, what we're giving you right now, especially in regard to networking, is the networking aspect that you need to get a full understanding of all the skills that you're going to be learning on later, especially in regard to Linux. So to just give you a background of what I did when we're going through the networking bit in class, I signed up for a Cisco networking associate class, and I went through half of that. So in most cases, when someone tells you go do homework about ABC, just don't just do ABC. Try to get a bit deeper and see how things function underneath the hood. Because when you know how something functions deeper, an interviewer cannot throw you off. I've been in scenarios whereby I'm in an interview and they ask you what's the default gateway. Have you guys done that already? Do you know what a default gateway is? Yes, someone just say yes.
Yeah.
All right. Yeah. So someone asks you what's a default gateway, and then they can go ahead and ask you maybe something like what should be the IP of the default gateway. How would you guys answer that?
So let me try. So the default gateway is the IP address of the router.
All right.
So amazing. Yeah. So let's say I mean, we haven't done how to get like the IP address of the default gateway.
Okay.
What we just learned was like the default gateway or whatever IP address of the default gateway is the router.
Amazing. Yeah, that's amazing.
Are you sure, Jonathan, we haven't done how to get the default gateway IP? Are you sure about that?
I mean, I know we did configuration.
I think when we do the IP config on the CMD, we can get the default gateway
Thank
IP.
you. Thank you, Faith. At least.
I nearly threw you under the
bus.
All right, guys. Let me do a screen share. Let me do a screen share and start off with that as our teaser for today. All right. Can you guys see my screen?
Yes.
All right. So I'm rushing through it. So what I did, I went on my Windows tab, I right-clicked, and then I went to Windows PowerShell admin. And this opens up this my prompt. So which command we use to get the default gateway or the IP configuration of our systems?
It's IP config.
IP config. Amazing. What if I need to know more details about it? How do I go about that?
IP config /all.
Amazing, guys. All right. Seems like you guys are doing your homework. That's amazing. All right. And then the other way that I can go to this prompt is just by coming here and I type CMD. See? And then I press enter. And then I can also do the same thing again right here, IP config /all. And then I get the same output that I have in here. All right, so let me see, let's find out what the default gateway of my system is, of my network. All right, so my default gateway right here is this right here. It ends with a 253.1. Can you guys see that?
Yes.
All right, so my network starts from a 253.0, and then it ends on a 253, usually it's a 254. So does the default gateway really has to always be 0.1 to start with 0.1? That's the question I had for you guys. Does it always have to start with 0.1? Does it have to be the first IP address on the network? It's just a brain teaser.
No, it doesn't have to.
All right, can you explain? Can you just give me a justification of your?
Like point one, from what I understand, is a host. It can be a host. So it depends on how many devices you add into your network. So the more you add your devices, the more the numbers can change.
Not exactly, because remember what Jonathan said? Jonathan told us that the default gateway is the IP address of the router, right?
Yeah,
All
so
right.
I think it has to be like static. So it has to be one, so that any other host that is assigned can be given a number that is maybe 2, 3, or 4, or 5. I don't
All
know.
right. All right. Yeah. All right. So that was just a brain teaser. Usually the first, the IP address of the router usually is a starting IP in the when you're assigning IP addresses. So if my router was 253.2, that would be the default gateway, and I would start from 2.2 to assign IP addresses and going on and on. So whatever the IP address of your router is, usually that is the default gateway. Because what's the definition of a gateway, of the default gateway? Jonathan, you gave us that already. What's the definition of a default gateway?
Yeah, so it's just the IP address of the router. So on the network, your router is known by this IP address.
All right, I'm going to cut you short a bit. What's a gateway?
So a gateway is, let's say, if you are communicating with the outside world, which is the internet, all your IP address comes through the NAT, then through the gateway, before it can communicate to the outside world.
All right, guys, have you guys heard that? Because that is a very introductory question that a recruiter can ask you, because recruiters are given questions to ask. Like, use these questions to weed out, people who don't know what they're talking about. So just from the name itself, default gateway, it should give you a hint. It's a gateway. That means, guess what? Okay, this is where our data or our packets are going to be entering into our network and exiting the network. So based on the name, you can be able to hint on what the definition is. So our gateway that's where the packets or the data is going to be coming in or getting out of our network on a simple definition. But today, that's not what we are going to be talking about. So today we are going to be talking about networking fundamentals. All right, can you guys mute? I can hear some noise in the background. Can you guys see my screen?
Yes.
All right, Jared, what time is the break? Gerard?
Yes, sir.
What time do they take the break?
The break should be after an hour and a half. So.
All right, around 11:30-ish.
Yes.
Okay, cool. So guys, today we're going to talk about networking fundamentals. And first of all, I'm going to go through the topics that we're going to be covering. And it's going to be pretty hands-on. So the first topics are going to be an introduction, where I'm just going to be giving guys definitions of different terminology, what the different terminology mean. And remember what we said, you need to master the fundamentals. If you don't know the fundamentals, that means you cannot build. If you build a house and you don't have a good foundation, that means whatever you're going to be building upon that is not going to be solid. So some of the basic terminology that we're going to be talking about are computer physical components, the devices, interworking devices, the network devices. We're going to be talking about those. We're going to be talking about characteristics of a network and things like topology. We're going to be talking about things like IPv4 addressing. We're going to talk about the OSI model and the TCP IP models. We shall talk about subnetting. We're going to talk about switches during this. We're going to talk about port boards and functions. We're going to talk about VLANs and VLANs and VLAN fundamentals, routers and routing basics, DNS and DHCP, network address translation. And we're also going to go ahead and do troubleshooting methodologies. How do you go about troubleshooting a network issue? For instance, if I was trying to SSH into a server, or if I was trying to ping a server and I don't get a response from that server, how do I go about diagnosing what the issue is? And like I said, it's going to be the first lessons are going to be more theory, but later we're going to be a lot of hands-on, whereby I need you guys to be able to tinker around and play around with your systems and set up virtual machines and being able to do things like pinging one, and then using other things like traceroute and other commands and other protocols to be able to figure out why a network is not responding, or in order to make two or more networks communicate with each other. So this is a brief overview of what we're going to be talking about in this regard. So it's going to be basically basic networking terminology. So we're going to look at things like the internet, modem, routers, laptops, desktops, things like switches, things like network interface cards. So in case you have any questions right now, please, any questions? The silence means no questions, right?
Yes, no question.
All right. So the first thing that we're going to look at right now is the NIC, which is the network interface card. I think you guys have done that with Gerard in class. So on your laptops or on your computers, there are two ways that you can your computers can transfer data. You can use the RJ45 cable, which is right here, the white cable. And when you plug this into your computer, the Ethernet cable, that is used to transfer data between computers on your network. So the network interface card, other names for the network interface card are the network interface controller. It can also be called the network adapter. It can also be called the local area network adapter, also called the physical network interface. So right here, if you guys can see this right here to my upper right, this is a diagram of a NIC. So this is when you open up the computer, for instance, where this white RJ45 cable is plugged in. That is how the NIC looks like. Any questions, guys? All right, do you guys have an which kind of ports do you guys have on your laptops? That was the question. I was asking which kind of ports you guys have on your laptops.
Peripheral port.
That is general. That is for all the ports. Peripheral ports are it's just like saying external ports. So which kind of ports?
Unfortunately for me, I have my Mac doesn't have any ports, so I have to. But normally, my other Windows have the network port where you can also connect directly to the wall.
So you're saying your laptop doesn't have any kind of ports where you can plug in any?
Yeah, not the MacBook.
So, America, your MacBook doesn't have an HDMI port or a USB port. Is that what you're saying?
Oh, it has. Okay. It has USB. I thought he was talking about network.
No. Any ports like
any port? Okay, yeah, it has USB.
Okay, it has a USB.
Yeah, only USB. I thought you were talking about the Ethernet cable.
No. I just wanted you guys to just give me the ports you've learned. That's what I'm trying to ascertain right now. Okay. I want to know which ports I've learned on your laptops. Like I do have this port. For instance, you do have a port for the power. You should have something like maybe HDMI ports. Should have USB USB-C and USB-C, USB-B and USB-C ports. So most of the most recent laptops don't have the RJ45 where you can plug the Ethernet cable in here. Because guess what? Nowadays, manufacturers are making laptops more portable, right? So because they're making these laptops more portable and smaller, the RJ45 is too big. So that's why they do have these network adapters. Can you guys see the network adapter to my right? Right here?
Yes.
So on one side, which kind of port is that on this side that where my cursor is?
RJ45.
Are you guys seeing that? And then which one is this on this side here?
Is it a USB?
Yeah, this is a USB. So you can get this for about $7 on Amazon. So one side is the RJ45 and one side is a USB. So this is an Ethernet to USB adapter. So what does it do? Can someone tell me what this does?
It's used to share network between computers.
That is a general concept of what an Ethernet adapter does. But I'm just saying this right here, just this adapter right here, the Ethernet USB adapter. What does it do?
So it brings like internet to your local area network.
All right.
So you connect your RJ45 to the port, the cable, then it brings like is it analog like signal?
Whoa, you're confusing me, Jonathan.
Okay.
All right.
It brings
Guys,
internet into your device.
Analog. All right, guys. This converts the input of an RJ45 to USB, which your device can use. Because we said, guess what? Most of the most recent devices don't have a port for the RJ45, right? So because you don't have that, manufacturers have come up with these simple other devices that can help you convert an input from an RJ45 to an input of a USB, which you can plug into your computer. So your RJ45 will go in here and you plug this side into your computer and you should be able to use it. And your network interface card, which has which should have a USB port on this interface to be able to access network. So guys, this is the NIC. This is the network interface card. So what does it do? What's the function of the network interface card? So a network interface card is a computer hardware component, and it connects a computer or a device to a network. So you can have those for an iPad, you can have those for a laptop, even a phone. And some NICs are even wireless. So guess what, you guys remember this is a NIC right here that I've showed you, and this is an RJ45 plugged into a NIC. So this right here is plugged in here, and this part right here is inside this laptop or computer right here. And we said it connects this right here, which is your computer, to your network. Guys, is that clear? Do you guys have any questions about that? Does that make sense? Yes?
Yes, sir.
All right. All right, so what did we say NIC is? What does a NIC do? What is a NIC? Can someone tell me what a NIC is?
Network interface card.
Yeah, apart from Jonathan, can someone else tell me what a NIC is? Can someone give me a definition of what a NIC is and what it does? I'm waiting for an answer.
It provides internet.
Can you say that again?
It provides internet.
It provides internet. All right.
Controls the data flow between the computer and the network.
All right, Faith, can you come again?
That it controls the data flow between the computer and the network.
It controls it connects a computer to the network.
Okay.
So it's a computer hardware component, and it connects a computer to the network. It does not control it. So that's why I broke it up into two. So it's a hardware component because it's right here. We saw it right here. And what does it do? It just connects a computer or device to a network. So I gave you an example here of the RJ45 and the NIC. And the NIC was connecting this computer here to the network. All right, guys, after that, we're going to computer networks. Have you guys touched a bit of about computer networking with Gerard?
Quick question,
Yes.
Charles.
Yeah, sure.
Can you go back to slide 7 real quick? I'm sorry.
What was the question?
Slide 7. I saw that you said examples of NIC, iPad, laptops. So I would say that those are the software, the hardware that we use that has NIC inside, because I remember that there was this chipset that was shown that says that's a NIC. I just wanted to understand why we had examples of iPad.
So
and laptop
these are examples of devices
that
on the
have NIC in
network
them.
that have NICs, yes.
Okay, gotcha.
And these network interface cards can either be physical, like here we do have this physical one, or they can be wireless.
Okay.
All right.
Thank you, Charles.
You're welcome. All right, guys. Now let's talk about computer networks. So what do computer networks actually do? So just like how you can go on LinkedIn and set up your account and say, guess what? I'm trying to network so that I can get a job. That means you're trying to connect to people. But in this case, when you say computer networks, it's not a people network. It's a network of devices. It's a network of computers. And this allows connections to websites on the internet. For instance, Facebook, Google. So in its basic form, a computer network is two computers connected via cable, and these computers are sharing information with each other. As simple as that. If I can plug my laptop to a different computer or to another computer or to your computer using a cable or using some kind of protocol for them to communicate together, that's already a network or a computer network. And that is in its simplest form. So this is before we go into the internet and then wide area networks or metropolitan networks. So in its basic form, a computer network is two computers connected via cable, sharing information with each other. So the kind of information that these computers can share include files. Can you guys give me another example of which kind of information computers can share together with each other? Applications. What else?
Data.
Data, yeah. Data, yeah, that's more general, but yeah, but that's true. So guess what, guys? Right here, I built an amazing network. I do have my laptop, and I connected my laptop to a PC. And which cable did I use right here, guys? RJ45. You guys have already done that in class. So I'm using an RJ45 to connect my laptop to my PC. And guess what? After that, I can do a data transfer between these two devices. So if I do not have an RJ45, which other ways can I connect these two devices? You guys use it every time when you go to your friends' houses. Hey, can I connect to your what? Wi-Fi. You see? So that means as soon as I walk into someone's house and I ask for their Wi-Fi password, I'm connecting to their router. And through the router, I'm going out to the internet. And when I go to the internet, guess what I'm doing? I'm getting some information from websites. I'm getting information from Google. I'm getting information from Facebook. I've already established a network right there. Is this making sense, guys? Yeah. Is it
I
making
have a quick question.
Yes.
Sure.
Yeah, the question is for the class. Let me just throw it out there. So look at the diagram with the laptop and the PC connected together in that local area network. And if you guys look at the diagram, well, you realize that there is no server involved, right? It's just a cable linking the two computers together. So how do we call that type of connection, that kind of network?
Peer-to-peer
Excellent.
network.
Excellent. You guys are sharp. I'm happy.
Geniuses, right? Woo! I can't wait. We're getting these jobs. I almost said no Indians coming, but that was racist. Want to be on NBC News.
I have one question, please.
Yeah, sure. Yep.
Going back to slide 9 and using that this computer network diagram which you've shown here, can you also link the computers with the docking station?
Docking station?
Yeah.
Can you link? Yes, but what does a docking station do?
It helps these devices to connect together. Is that like you want to use two devices simultaneously?
Yeah, so a docking station is used on one device.
Let me answer that question for him.
Yeah, sure, Kingsley.
So Jarvis, a docking station, right? The purpose of a docking station is just for you to connect multiple devices. It's same like you just connecting your laptop to an external screen. But if you want to do like extra 3 screens, you can use a docking station because it has multiple ports on it. So a docking station also has a network port on it. So you can use a docking station. If both machines have a docking station, you can use a docking station to connect them. So long as it has an Ethernet port, you can connect a docking station peer-to-peer network, no matter what. So it's just like you plug it into a computer to a computer. But a docking station use is just to make you have more devices, more ports. That's a simple purpose of a docking station.
Thank you.
That makes sense?
Yeah, it does. Thank you.
Yeah, so a docking station is not really like 2 devices. It's like trying to have multiple ports accessibility so that you can be able to use your mouse, you can be able to use your keyboard. So, all right. So guys, here we do have a more complex computer network. So we have moved away from just 2 computers or 2 devices sharing information to more devices sharing or communicating with each other. So here we do have things like the internet, we do have the router, we do have the firewall, we do have switches, and behind the switch, we do have servers. We do have a file server, we do have a database server, we do have a web server. You guys have learned about servers, right? Can someone give me a yes if you want about servers? Just like
yeah.
All right, so what's the use of a file server? Can someone give me an answer?
Okay, so
it's not complicated. It's not complicated.
Let me try. So a file server could probably be like a server that has a particular file installed on it, so that if maybe a client make a request to that particular file, then the server will be able to give access or permission to the client.
Amazing. That's a very deep definition. Actually, I wasn't even looking for that. I wanted something as basic as a server that's used to store files, not even have someone querying and getting those files. So guys, servers, just like the name says, serving, that means I'm serving with something. So if I'm a file server, I'm going to be serving files. So that means someone who's going to be coming to me and making a request for a certain file. And when they make that request, I'm going to serve them based on the request that they come and ask of me. So if I'm a file server, if a server is a file server, when the request comes in, someone is requesting for a file, and that server will give someone the file that they have requested for. Same applies for a database server. You have databases on there. Those databases store certain information. So if someone queries that database, so guys, remember we said you need to learn the terminology. Querying a database, you can say if someone goes and gets data from the database, but if you say that in an interview, someone be like, getting data? How long have you been in the IT field? So when I say a word like query, guys, write it down. Like if I say query a database, write down query a database, and after that later on, instead of watching Netflix, go Google what does it mean to query a database. It basically just means getting the information you are requesting of this server right here. And then even a web server. That means I'm asking this server to give me a web page. For instance, if I go to www or www.facebook.com, guess what? I'm asking the Facebook server to give me a certain web page. All right, later on, we're going to learn about switches in more depth and what a switch does and how it forwards information. So this is an example of a bigger network. So all devices communicate with each other. So we have this network right here, and all these devices are communicating with each other. And guess what? The router might be manufactured by a different manufacturer. These servers don't necessarily have to be from the same manufacturer. This server right here may be from Dell, this may be from HP, and this may be a Windows server. They don't have to be from the same manufacturer, but guess what? These servers are these devices, even though they are from different manufacturers, are communicating with each other because there's a standard language based on the ASI model upon which these servers communicate with each other. So we shall look into that concept called interoperability later on, whereby there are different servers from different vendors, but they are able to operate and talk to each other. So we shall look at the Open Systems Interconnection model, which is a model that describes how networks should communicate. So guess what, guys? We said all these networks are talking to each other because there is a standard. There is a language of networking that all these devices right here are using to communicate with each other. So let me say, if, for instance, this server right here, maybe, let me go back a step. Let me switch slide. You can use to, okay, it's coming up next after this. All right, guys, we say there's a standard language that these devices use to communicate with each other. And that is called, the concept that describes that is called network protocol. So what is a network protocol? Guys, what is a protocol? Have you guys had the term before?
Yes.
A set of rules.
All right, it's right here, guys. It's a set of rules or conventions. And these rules, in regard to this network, these rules govern the communication between the network devices. That means if this device had a different set of rules and the switch had a different set of rules, they will not be able to communicate with each other. Does that make sense, guys?
Yes.
So computers on the same network have to speak the same language. And to just give you an example, just some of you speak French or may speak French and I speak English. Just imagine you're speaking French to me and I was responding in English. Guys, that wouldn't be effective. But since for instance, right now, I'm communicating in English and you guys understand what I'm communicating because we are using the same language. We're using the same protocol. We're using the same set of rules, which is this grammar that I'm using to communicate with you guys. Does that make sense? So let's assume right here, just explaining that concept further. This computer, let's assume this computer here uses English, and this computer right here is responding in French. Guys, there would not be effective communication between these two devices or these two computers. They need to have the same language. They need to have the same set of rules in order to communicate effectively, in order to exchange data and communicate with each other. So that is that's the other thing that we're going to be looking at. We're going to be looking at network protocols. You're going to be hearing things like DNS. You're going to hear terms like DHCP. You're going to be hearing terms like ping. You guys have already done ICMP protocol. Remember, I said if you understand the basics well, all this is going to be easy to understand. So network protocols are a set of rules or language that govern effective communication between devices or other devices. And we shall later on, we're going to talk about the OSI model, like I said, which is the Open Systems Interconnection Reference Model. And what the OSI model basically does, it provides a set of rules. And based on those set of rules, these devices are able to communicate effectively. So we shall look at 7 layers of the network protocols that are under the OSI model, the Open Systems Interconnection Reference Model. You guys should have questions by this time. Any questions? Or should I ask you guys questions?
One question, please. Could you please clarify the OSI model and protocols? I think I might have missed the explanation of those.
We shall go into the OSI model. I just wanted to bring it out here.
Okay.
Just like a hint. It's more in depth than that.
Okay.
So yeah, it's just a set of rules that computers or devices on the network use to communicate with each other. So for now, that should suffice.
Okay, all right.
Yeah, so make sure you understand right now, I just need you guys to know the basics and the terminology, so that when we're building upon that, you guys have a thorough understanding of what these terminology mean. So home network devices. So guys, which devices do you guys have in your home network? Networking devices do you guys have in your home network? And let's everyone name one device that you have in your home network.
Switch.
Sorry?
Switch, router, computer.
All right. You guys have switches in your home, at your home?
Ismail, you have a switch at home?
Try the modem.
Are you serious?
All right.
That's not a switch.
All right, you guys have, yeah, and this is a modem, yeah. Yeah, most of these guys can be, yeah, some of them could already be having switches. You're right. They're serious IT professionals. All right, yeah, we do have modems. Do you guys have things like Wi-Fi boosters and all that stuff?
Yeah, wireless access points.
Wireless access points, yes. So a router, so routers or modems. So in most cases, what your service providers will do, they'll put the routing capability into your modems. So a modem will act as a wireless access point, but at the same time, it will also act as a router. So that means it will receive information and feed it to your devices, and also route that information from your devices into the outside world. So the router will receive data, and after receiving that data, it will determine where to forward that data. So routers and switches move data based on some decision criteria. So we shall look at those decision criteria when you go in depth into the routers and the switches. So guys, right here, we do have an example of a home network. And I need someone to explain to me what's happening here. Can someone give this a shot?
Local area network.
All right, start from somewhere. Where are you starting from? Tell us where you're starting from. At least leave this lower bit about San Francisco, San Jose, New York. Leave that out, but just explain to me what's happening between the internet to right here, the laptops and desktop, the router, the modem.
The internet is ISP, and when we contact our ISP for internet connection, they get us a modem or a router, and most times the router and the modem can be integrated together, and the modem would actually, because the modem gets the internet connection and the internet signals as when he receives the internet signals, he receives it as an analog signal, because the router can understand an analog signal. So the modem helps it to convert the signal to a digital signal and gets it to the router. And then the router will be able to get that signal, the internet connection, into our laptops and our desktops that we use for our internet connection.
Awesome. Thanks. That's amazing. Someone else? Someone else wants to give this a try before we go on? All right, guys. When information is routed from your laptops to the internet, one thing that these networks are designed in such a way that you have to use the path of least resistance, or the path that won't cost you a lot. For instance, let me just give you guys an example. Let me assume someone wants to drive from San Jose or San Francisco to New York, or let me do it the other way around, from San Francisco to San Jose. Would it make sense to go from San Francisco to San Jose, or would it make sense to go from San Francisco to New York and then to San Jose?
So the least resistance, so from San Francisco to San Jose.
All right. Yeah, guys, the cost of traveling from San Francisco to San Jose is less than the cost of traveling from San Francisco to New York and San Jose. So when you're routing, for instance, when you're moving data from your computer and you're reaching out to the internet, that is one of the considerations that are made. The path which your data takes is going to be the shortest distance or the least expensive path from your laptop to the internet. Because when data is moving from your laptop or from your home environment to the internet, packets are being lost. The longer the distance, which word can I use that you guys can understand? The word is the latency, or the word is latency. The longer the distance, the latency becomes poor. But the closer the internet is to your home environment, or the resources you're trying to access from the internet are from your home environment, the shorter that distance is, the better the connectivity. So when we're doing routing, those are some of the considerations that are put in place. Route of the distance, or cost of the route of the distance, is one of the considerations that you have to put in place when you're designing your networks. So that is one concept that I wanted us to touch about. Later on, we're going to do one thing. I want you guys, we're going to use Packet Tracer to design a small office, home office. So this is going to be a project for later on that you guys will have to submit for grading, but this won't be right now. I want us to move to another activity. So this is going to be a hands-on. Guys, what is ping? You guys have done this already, right?
Yeah, when you are pinging something, that is, you are trying to find out if that particular server either has a working IP address or not.
All right. Can I have someone else giving me an answer apart from Faith, apart from Jonathan? How many are we in class today?
I think a ping, when you ping, you're trying to find out the route that you would take to connect to the server you're trying to access. So I remember in class, we tried to ping the Facebook address. I'm sorry, the Facebook server. And so that's what pinging is. Pinging is trying to find the route to connect of the server you're trying to access.
All right. So ping is used to test connectivity. It's like trying to call you. Like, hey, Gerard, are you there? And then I wait for a response from Gerard. If Gerard is there, he will say yes. If he's not there, it will be silent. So guys, can you guys open up your terminals? Just right click here and go to Windows PowerShell, or if you're a Mac user, go and search terminal. When you guys are done, let me know. Are you guys done? Have you opened up your terminals? Yes. Have you guys opened up your terminals?
Yes, it's open.
All right. Is Ola, are you online? Ola?
Always.
Ola, are you online?
Always, I'm online.
All right, can you ping facebook.com and let me know which response you get? Can everyone go ahead and ping facebook.com?
Yes, I've pinged. Packet sent equals to 4. Packet received equals 4. Loss equals 0. Percentage loss 0.
All right, so what, is that Ola?
No, that wasn't me.
Ola.
Minimum is 11 ms, maximum 16 ms, average 13 ms.
All right, so Ola, can you give me which IP address do you see when you ping facebook.com?
157.240.1935.
All right, someone else, can you give me your IP that you get when you ping Facebook?
Have 31.13.93.35.
All right, guys, we are getting, okay, the first concept is ping. So we have verified using ping that Facebook is up, right? We are getting connectivity to Facebook, right? So what would happen if the Facebook site was down? Would we still get a response? If Facebook went down, what would happen? Would we still get this response? Would you get a reply from Facebook?
No, the packets have been lost.
Senior Charles.
Yes.
Sorry, one question. It looks like when I pinged, the IP address that was given me, it's not what I'm seeing on the screen. It's not your typical like 157.240.220. It starts with 2803.2880.f 1 for like very long stuff.
IP.
So I don't know if I'm doing something wrong or.
No, you're not wrong. You're getting
No.
IPv6 instead
Yep.
of IPv4.
Oh, okay. And are they the same? Why? Like, are they the same?
So so IPv4 and IPv6 are different, but they do the same function.
Okay.
So we are migrating away from IPv4 to IPv6 because IPv4 addresses are running out. So most devices right now are set up for both IPv4 and IPv6. So those are the protocols do the same thing, but they do have different names. We shall talk about that later, IPv4 and IPv6. But if you're getting you can configure your internet settings in your computer to be able to receive packets through IPv4 only. But if you're getting something with something like letters mixed up with numbers, that's fine.
Okay.
Your system is set up to use both IPv4 and IPv6.
Okay.
Yeah.
Thank you.
Yeah. So the other thing that you guys should be asking is why are some of our IP addresses that we're receiving different? Why is mine 157.240.220.35 and yours could be different from this?
Let me try, sir.
Sure.
I think following what I understood from the last class with Mr. Gerard, it is because the server that is closest to where we are is where the one that will ping to.
Yes, that's one of the reasons. Good. Someone else?
And I think what I remember from the last classes, Facebook is a big company.
Mm-hmm.
So it has like different like IP addresses.
Yep.
Okay, sir, can I try some other point?
Yeah, sure.
Following what I've understood from the explanation you just gave previously, I think that the latency or the path that has least resistance is the one from where we are is the one that that the Facebook will ping to, that the computer will will ping to.
Yes. Guys, that's great. This is the kind of participation that I want from you guys, especially because you've gone through these concepts before class. There is this and that allows me to give you guys a bit more, because it shows me that you guys are ready to learn a bit more, especially what people who are already working like me and Jared and Kingsley do in a production environment.
Yes, sir, but you are going a little bit far behind, sir. We are diverting because we were talking about that. Suppose that we did not get a response from the pinging of the Facebook. What will we say?
We already answered that. The Facebook
Have not.
Facebook servers will be down.
Okay. Yeah, I'm saying that he said, suppose we do not get a response. How will we know here that we don't get a response?
Oh, right. That's a good question. Let's ping something that okay, I don't know of any site which is down right now. And I cannot bring the office network down to illustrate to you guys.
What if you entered in the Facebook address incorrectly? Would that matter?
Was someone saying something?
If the address is entered incorrectly.
All right, no, let's just go to a website that doesn't exist, because a website that does not exist won't give you, or a website that's down will not give you a response.
Facebook.net.
I did ping a website now and it said timed out, like one of the websites that I know is now.
Which one is that?
Olodo.com.
Which one?
It doesn't exist. It's LOLDO.com. And it just said request timed out.
Okay. Okay, guys, let me see. Me2you.com. Is that a website? Oh, me2you.com is a website. Okay, I didn't know. Okay, guys, if you ping a site which is down,
like in the last class we pinged, I think we pinged emekaola.com and it didn't exist, right? And
Yes,
that was the
Charles.
example we used.
All right. So guys, yeah, if a website that it doesn't exist, it won't give you a response back.
Yeah. So Charles, ping something like Gerald me or Gerald Charles or something. Yeah, that's another good example. Bad request.
Yeah. Request could not find host gerald.com. Please check the name and try again. So to get a good one, you usually just get a response like
Can we try Toys R Us? I know they went bankrupt some time ago.
yeah, that site should be up because they want someone to buy it off. Toy.
Toys R Us, like SRUS US.com.
Yeah, they cannot keep the domain down because someone will buy it up very fast. Let me see. Let me try to search for something on my network that could be down. 86, no, 86, I must have used it. All right, guys, I am not able to find something on my network that's down on IP. Okay, right here, you see destination host unreachable. Can you guys see that?
Yes.
Yeah, usually that's what you will get when you ping, for instance, Facebook, and you do not get a response. It should give you something like destination host unreachable. So that's what happens when you ping a site and that site is down. It will give you a destination host unreachable. So let's go back to Facebook. So I'm still getting the same.
I actually pinged sourcerush.com, and it's saying that it's not available. It's not up. So I went and I looked at the sourcerush.com, and the website is not available either.
All right, good, awesome. You can post the command that you used to the site that you used to ping in the chat so that someone else can try it out. All right, guys. Before I forget, we're talking about you guys. Told me something you did previously in class, and I wanted to explain the concept of you guys getting different IP addresses. And one of the reasons we talked about is latency. So these big companies like Facebook.com, or we could also do, guys, we could also do not only Facebook, we could also ping Google.com. These companies have data centers in different places. So Facebook could have a data center in the East Coast. They could have a data center in the West Coast. They could have a data center maybe down in Texas. So that when people are trying to query their servers for information, these servers for information, they do go to the servers that's closest to them. So people who are on the East Coast will query the servers that are in the East Coast for data. People who are on the West Coast will query servers on the West Coast for data. People who are in Texas or in that region, the Houston region, will query the Facebook servers or data centers that are in the Houston region for the web services or the web servers that they need or the information they need to get from Facebook or Google. So guys, why is it like that? We talked about the latency. If I'm getting information from here in Boston compared to someone who's querying a server on the West Coast in California, the latency or the response time for someone who is in Boston will be shorter if the data center for Facebook is in Boston compared to someone who is in the West Coast. So that is the concept of latency and data centers. So that's one of the reasons why we do have the different IP addresses. You may have a different one. I may have a different IP address. We have someone in Boston on the chat.
Yes, Brockton.
All right, Jonathan, try to ping facebook.com and tell us the IP that you will get. And then the other reason is load balancing. So usually all these, when you query a data center and a server, all the requests don't go to one server. I don't think you guys need to know about load balancing right now. Let's leave that. Let's leave load balancing. For now, let's just move on. All right, Jonathan, which IP address are you getting? Let me just get an IP address.
So my IP address is the version 6. So it's very long and
all right, that's fine. That's fine. Guys, we shall talk about, maybe we shall hint a bit about load balancing later, but don't forget that concept. You can just go read about load balancing. Just make a simple note about load balancing so that you can read about that. I think for now, this should be able to explain the concept of testing network connectivity between two devices or two servers. And for this, in this case, we're using Facebook. But for instance, right now, I'm in my office network. If I do an IP config, I should be able to get my IP address. Guys, my IP address is right here. It's a 0.62. But I could also verify connectivity to a different device on the same network. So let me do a ping. So I'm pinging a certain device on my network from my laptop, which has a 0.62 IP. So let me do 253.58. So I'm getting a response from another device, which is a 253.58, which is on my network. To make it better, let me get a server that I know by name. All right, guys, we do have a Confluence server. Have you guys heard about Confluence before? So Confluence is just a server that we use for sharing information. So for instance, if, for instance, right now I did some documentation, I did a ticket and I want to do some documentation, we use Confluence for documentation. But if someone comes to me and tells me, Charles, I am not able to access Confluence. So what's the first step that I do? Or what would if someone came and told you, Charles, I cannot, maybe Jonathan or Emeka or Ola, I cannot access Confluence. How would you go about that? What's the first step you do? Would you run to the server room?
No, you ping confluence.com to see if you can get any reply.
Amazing, guys. You just sit on your desktop right here. You power up a command line and you just ping confluence.com. So when you ping confluence.com or you ping that certain server that has Confluence, it gives you a response. What does that tell you? It tells you, guess what? Confluence is already up. Confluence is running. The server is not down. At least now we know the issue. Now these are the troubleshooting things we're going to be doing later. At least now we know that Confluence is up. So I've given you an example of ping and how we can use ping to make sure that a certain server is up. So yeah, sure.
If the server is behind like a VPN, do we just still ping it directly like this and we'll still get a response?
If the server is behind a VPN or a firewall?
A firewall.
So usually, yes, when you, for instance, the way a network is set up, a network is set up in such a way that what a firewall does, it prevents people who are not on that network from accessing it, from accessing resources on a network. And So for instance, when you're setting up firewall rules, you set up rules that say allow Jonathan or allow Ola or allow Charles or allow devices on the 253. For instance, look at this. The server that I just pinged conference.com is on this network right here. Actually, let me see. Is this my conference.com? That doesn't look like my conference.com. Guys, just give me a moment right now. Let me go to party. So actually the conference that I did was the main conference server on the internet, not my conference in my environment. Just a moment. There's a concept that I need us to. Have you guys used Party?
No.
All right. All right, this is what I need. That right there, not the main conference on the internet. Gerard, why didn't you catch me when I did that? All right, guys. So when someone comes and tells me, Charles, Confluence is down, I cannot reach Confluence, which is our resource which is a server that we use for sharing information within our environment here at work. So guys, later on, I know I'm feeding you guys with too much, but right now I use Party to access a Linux server right here. And my server right here has this IP address right here. And I was able to ping that server. If this definitely, if this was done, I wouldn't be able to access this page right here. But I do have this documented somewhere else on a resource in the internal network, which is an inventory, which points this which points this IP address to this server. But I was able to ping Confluence, which is a resource sharing server in my environment. And I was able to get a response. And since I'm able to get a response from Confluence, that means, guess what? Confluence is up. That means I can use I can go to my next step in the troubleshooting. All right, guys, we have looked about ping and what ping does. And we have seen that when we did a ping on Facebook, it gave us a response. And the response that we got was a response from 157.240.220.35. So my other question is, why is it that it replied us with a number, yet we used letters, facebook.com, which is a word, to ping the server? Did you guys get my question?
Yeah, because there'll be no way for us to remember those numbers of every website's name, every host's name. So that's why
Are you sure there's no way for us to remember that?
It's not as if there's no way, but having us to cram all the numbers of all the website numbers will be sort of difficult for us to do. So that's why it's changed into a name. And then the IP address, which is the domain name system, changes the name to an IP address for us to get our network.
All right.
Or something, yeah.
All right. Guys, that's one way of answering it and looking at it. Does someone else have something to add in addition to that?
I think probably based on the lectures from last week. So this is where like a DNS server comes in. So we as human understand the facebook.com, but when it comes to computers, they don't understand the facebook.com, but they understand these numbers like 15, they understand numbers. So DNS server is able to translate the facebook.com into numbers in which the computer can understand. So when you type in the facebook.com, the computer can understand the numbers. That's why we see just the IP address for facebook.com. I don't know if it makes sense.
Guys, does that make sense? You expanded on what she talked about. I forget your name. What's your name? Emeka? Is it Emeka?
Yes. No, that's Jonathan.
No. The lady, Emeka, right?
Oh no, that's
Faith.
Faith, yeah. So Jonathan expounded on what Faith said. Guys, we talked about it. Computers understand a certain language, and we understand a different language. So guess what? Just assume all these were numbers. This right here, instead of words, a computer would be able to figure out what it is, because that is a protocol that a computer understands. So later on, we shall go ahead and talk about DNS and domain name translation. And we shall talk about things like DNS server. So when I ping facebook.com, I use a language that I understand. Guys, right here, look. Which language do we use? We use English. I said www.ping.facebook.com. And then when we got back a response, we got back that response in a, let me see, where's my command line? Right here, we got back a response with an IP address, not reply from facebook.com, because a computer is replying to us in a language that it understands, using a protocol that it understands, which is different from what we humans understand better. We humans are more of wadi, and then computers are more of like numbers. That's the language that they use. That's a protocol that they use to communicate when they're replying to us. So guys, that's one thing that I wanted us to discuss.
Charles, please, I have a question.
Sure, please.
Yeah, you're talking about ping, and you've been talking about protocols. So I guess like I just pinged Facebook from now, and I got an IP address. But I want to understand something just looking at this Windows PowerShell, this command line interface that's in front of me. When you ping, what actually happens? I mean, what are the protocols? Can you explain what actually happens in the communication? And is it possible to see that those protocols on this command line interface?
Is it possible to see what, sorry?
It is possible to see the protocols, the communication that's happening between, for example, my computer here on the Facebook server. When you ping it, is it possible to see these protocols in this command line interface? And can you also explain what happens when you ping Facebook server, for example?
All right, guys. What someone explain to that? Okay, let's say ping facebook.com. Someone explain to us what was happening. All right. What did our server do? I just highlighted it right there.
Yeah, it sent 4 packets, and we see 4 packets. But my question is linked to I think my question is linked to the network protocols. Like when you ping a server, what's happening? Like, can you explain to me like the routes? I mean, kind of the protocols that happen.
We're going to talk about in traceroute, which is the next one. But ping is a command. Which protocol does ping use when it's communicating to other servers? You guys we talked about it today. Which protocol does ping use?
domain name?
Is it
No.
IP address?
Sorry?
Is it TCP?
It's
No.
IMCP.
ICMP, Internet Control Message Protocol. So there's a message protocol that your server uses when it's pinging. So in that message protocol, what it's doing, it sends out packets to the other server. When the other server receives those packets, it replies, hey, guess what? I received these packets. So sent 4 and then received 4. So when you ping, you're using the ICMP protocol. Let me put it in here. Guys, go and read about the ICMP protocol, Internet Control Message Protocol. That's the protocol that the ping command uses to send a message to the other server to test if it's active, to test if it's up. And when the other server is up, it will respond like, hey, I was able to receive your messages. So before we
Charles,
go
I think it's part of their homework. For those who've gone through the homework, you're gonna see ping, you're gonna see ICMP. So if you started going through the homework, then you should be familiar with ping and ICMP. But if you haven't, then it'll sound foreign to you. So guys, make time and go through the homework. Thank you.
All right, guys. So what ICMP does, it sends out an echo request to the other server. If the other server is active, it will broadcast back an echo response. So on a basic level, that's what you should know right now about the ICMP and ping command. But you asked another question. How do we know which route does this ping or the ICMP or ping take to get from our server to facebook.com? So before we do have 3 more minutes before our break. So let's go ahead and do a trace route to facebook.com. Everyone fire up your command, your command prompts, and do a trace route to facebook.com.
Charles, trace set will work. Trace route is not gonna work. I think for Windows, trace set is gonna work.
All right, let me see.
If you do a trace route, it's not gonna work. I don't think so.
These days, Windows is trying to. Yeah, you're right. Trace set. All right, guys, let's do a trace out to facebook.com. Are you guys doing that? Can someone give me a yes?
Yes.
All right, good. Let me know when you're all complete with that. I'm going to be asking one by one. Ebenezer, are you all set? Ebenezer, are you on? Javis?
Yes.
Javis, are you on?
Yeah, I am.
All right. Ola, are you all set?
Yes.
All right, good. So guys, traceat is another command. So what does traceat do? It gives us the hops. So when information or packets are moving from your computer, for instance, you say, I want to log into Facebook. I want to access my Facebook page. How is that request moving from my phone or from my laptop to the Facebook site? So these hops give you the routers on which your network or your packets are hopping from and to. So let me give you an example here. I'm starting from my gateway. Guys, remember the router? This right here is the IP of my router. So the packets that I'm sending out, or the requests that I'm sending out, goes through my router right here, or the internet gateway, which is the IP address of my router. And after that, where does it jump to next? This should be Boston MA, BSTN MA, and it's a Verizon router. So it jumps to another Verizon router right here. And after that, it jumps to another Verizon router right here. And guys, we do have two different timeouts here. Some people, or some other times you get a timeout because some people do not allow, or some sensitive data centers won't allow you to use their data they won't allow their data center names to be displayed to the public. So that's why you see a timeout. But after that, we do have it somewhere in New York. You see NYC. And then we do have a Facebook gateway. Guess what? It started from my gateway right here, AWGW, alias wire gateway. And guess what? Now I'm getting into the Facebook gateway, .customer.alter.net. So guys, this information started from my gateway right here. And all of a sudden, guess what? It's at the Facebook gateway. That means I'm getting into the network, the Facebook environment, or the Facebook data center. So this is showing us that the packets are hopping from my gateway right here to the router, to the Verizon router. This is the router that I do have in my environment because I know what my IP is. And it is going to another router right here. And after that, we're finding it right here, somewhere in New York, another router in New York. And then it still gets to the Facebook gateway right here. So traceroute will show you the hops of where the data is moving from your gateway to the resource that you're asking for, which is this right here. So traceat, not traceroute, because I'm so used to the Linux side of things. Traceat right here is tracing the route that our packets are taking to reach to the Facebook gateway. All right, guys, it's time for your break. If you have any questions, please you ask them after the break. Jared, how long is the break?
He promised us 1 hour for break every day now.
It's 10. A good 10. So Charles, you can pull up the Google timer, the 10-minute timer from Google.
All right. All right, guys, we were talking about the traceroute command. And I just gave you an illustration. We traced our route, and I guess each one of you was able to do that. You're able to trace your route from your machine to Facebook. So I need someone to do a trace route. I need, have you all done this, by the way? Because I'm going to be calling out each person to give me the details of their hops, the routers between which your packets were hopping to get to your final destination. Bismarck, are you there? Bismarck? Do we have Bismarck? Can you guys hear me? Can anyone hear me?
Yes, we can.
Yes.
Oh. I can hear you loud and clear.
All right. Do we have Bismarck here? Because I can see Bismarck right here. It says we do. I need to get to know you guys by face. Bismarck, Andu. All right, Bismarck is not on this phone call. On this. All right, Ebenezer. Ebenezer, are you there? Imeka, are you there? Faith, are you there?
I'm here.
Faith.
Yeah, I'm here.
All right, cool. Wow. All right. All right. Can I need some? So, Faith, did you trace that to Facebook or Google.com?
Yeah, I did it with Facebook.com.
All right. Could you explain to me what happens when you do a tracer to Facebook.com?
Yeah, I wanted to actually ask a question on that because do you live in Boston?
Yeah, I live in Boston. Yes.
Okay, because my own trace route was quite different from yours because yours went through New York.
Yeah, it does not have to be the same. Yep, that's a concept that we need to I need to clarify. So the route is to the servers, the routers that are closest to you.
Yeah, but if you're in Boston, you should go through the one that's closest to you. So I was wondering why you had to go to New York, even I'm also in Boston, and mine went through Needham, Massachusetts.
Okay.
Or maybe is it because your ISPS is different? Or what ISPS do you?
I'm using Verizon. Which one?
Oh, okay, maybe. Okay, so mine.
Can we get someone who is not from the East Coast? Can we get someone maybe from Texas to give us theirs? Because you and I should have comparable, should also both be resolved into New York.
Yeah, I think mine is really quite different from all of yours because I'm in Sweden.
Okay, Sweden, that's amazing.
Yeah.
Yeah, let's have someone from Sweden telling us what they're saying. Yeah.
I see something completely different. I mean, I see here Karlstad, which is where I am.
Mm-hmm.
I can see SK, Schmidt, I don't know if that's Stockholm. And then, yeah, I also have a request timeout. Of course, I can see my ISP from him.
So does it stay in Sweden or does it resolve to a data center somewhere in the US? So because that can tell us where your data center is. Does it cross to a different country, maybe a different city?
I mean, I'm unable to see that because of the abbreviation, the letters.
Okay, cool.
Yeah. But I think it stays in Sweden.
All right. So that means Facebook does have a data center in Sweden where all your requests will resolve to. So that is the data center that's closest to you, those that contains the servers that are closest to you. So it doesn't make sense for someone that is in Sweden to be resolving to New York or somewhere in the US in the East Coast, because the latency would be very, very, very there will be greater latency. So usually what these big companies do, they do have data centers in different regions. And they always resolve to the regions. You always resolve to the region that's closest to you. So guys, can you see my screen?
Yes.
So trace that command. So the command that's used to show several details about the path that a packet takes from the computer or device to a specific location or destination. So the specific destination, right, for our case was Facebook that we did. This shows each hop or devices that you go through to get to Facebook. So I need you guys to read more about the traceSite command and the options. Can you guys note that down? Read more about the traceSite command, because the next lesson I'm going to be asking you guys questions about that. So guys, the other thing that we're going to look up about to.
I want to ask, are you going to leave the notes for us?
Sorry?
Are you going to leave the notes for us on the Slack?
Actually, I wanted you guys to make your own notes. That's what I was thinking.
I have a question, Mr. Charles.
But I'll give you the notes. But this is just
Yeah,
the
we
intro.
we can expatiate on the notes you give to us. We can go more in depth on it.
All right, cool. All right.
I have a question, Mr. Charles.
Sure.
So I try to ping a web address, and when I try to ping the web address,
You're
it
trying
says
to
request. It says request time out. Okay, and then it says firewall report unreachable.
so you're trying to ping a web address and it's giving you a request timed out.
Yeah, but it says because I've not seen this one before. It says from the firewall.wn.com, which is they give me the IP address for that firewall, and then it says destination port unreachable. So is that why am I getting a message from the firewall?
Can you write that question in the chat so that because I cannot hear you, there's some.
Hello, can you hear me?
Can you guys mute? Everyone else, can you mute? All right, can you ask the question again, Emeka?
Okay, I tried to ping a website and I got a message from the firewall, and
Whose
it says
firewall?
destination. It says firewall one.wn.com, and then it gives me the IP address, and then it says destination port unreachable.
So which website are you trying to reach?
What I pinged was nnpc.com.
Have you accessed that website before?
No, I never accessed the website before.
Is it an arbitrary website that you are accessing? Like you just thought about a name and you're trying to reach it?
Yes, because I know they have another website which is nnpcgroup.com.
Okay.
So I just said let me try nnpc.com, but I was getting a firewall. So why am I getting a message from the firewall?
All right. I don't know what they did on their side, but usually when said this, there's something wrong with this with my network here. But usually when said destination unreachable, it could be either the website is down or they've just changed the ports on which you have to access the data that you're requesting for. So it could be maybe the DNS resolution has the DNS resolution for the website has been changed. So it could be any number of reasons why you cannot reach it right now based on the message that you're getting. And usually it could, based on the error you get, if it's an error in the 500 region, like 500 digits, it means it's a server side error. If it's in the 400, it's on the client side. So it could be any of those reasons, or even some other reasons that I have not just stated. Jared, I think it's something with the network. I'm not sure if it's mine, but can you guys hear me well?
Yeah, we're getting some echoes coming from your side. It's like you're talking 2 or 3 times. We can get a background echo following after you speak.
Yeah, I think I'm getting that from you too. I don't know why. All right. So let's try and see if, yeah, I can still get it. Can we restart maybe?
Sir.
Hello?
I think Charles, if we could try to disconnect and come back in, and probably it probably would help.
Let me
Yeah,
try.
Charles, just drop out and come back in. Yeah.
Yep. I said restart, like restarting a server, like.
Extra break time, right?
Maybe I should be asking questions before he comes. What do you guys think?
No, we should ask is what should be a good ping time?
A good what?
A good ping time.
A good ping time?
Yes, sir.
What do you mean by a good ping time?
Because I understand ping is used one to trace the route. I mean, ping is used to send a request and get the feedback, and it's equally used to know the length of time that it takes for the request to come back. Okay, now that time that it takes to know the request to come back is called TTL. What I'm trying to find out
Time
is
to
it
leave.
good to have,
That's
yeah. Yes. Is it about what should be a good TTL for a data package to come back to the client computer from the
I think I'm still getting some background noises. Is that true for everyone?
Yeah, I'm getting background noises. I'm still getting this. I think it's the same issue here.
Okay. I don't know. Let me check my own network from here. Network is good.
Guys, you can use fast.com. Can you, if you go to fast.com, you guys should be able to know what your network speed is. Just open up a browser, fire up a browser and say fast.com. It should be able to give you what your network speeds are.
Upload and download speeds. So that's how you can check and call your ISP and tell them you are paying for one thing and you are getting another. If they tell you this is what you're supposed to be getting, you're supposed to be getting 300 megs of upload and download or vice versa, whatever. That's how you can come check the internet speed and actually know if what you're paying for is actually what you're getting. Because sometimes you can be paying for that, but you're getting something else. So it's gonna give you your upload and download speeds. And then you can double check that with your ISP and ask them, okay, how much is my bill? What is my upload speed and what is my download speed? And then you compare with what you're getting, if it's close enough. If it's far from those numbers, then they're probably just harvesting your money and giving you something else.
What's the ideal speed to have?
It, like I said, it depends on your plan, what you're paying for. It's, you know, mine, I'll go for the fastest speeds. You know, I think my download is like 300 megs. Upload is like 20 megs. I've forgotten.
And the RAM can affect the speed, is that correct?
Say that again.
The hardware settings like RAM and space storage and its
No. We're talking about the speed of data transfer over the internet. We're not talking about data transfer within your system. If you're talking about within your system, that's where RAM is going to come in and all those things. But upload and download speeds when you're dealing over the network, over the internet, it's different. So things like something like that will be affected by your network bandwidth, network throughput. Those are things that will affect your speed.
I have a question. So you remember before in the beginning of the internet when you used to connect to the phone and you had this blah, blah, blah. Can you elaborate based on what we're talking about, right? Is it because there was no router? That's why we used to have hit a dial tone and there was dial first, like and then there was dial the numbers like it's dialing a fax. It's like calling a fax.
Yeah. So that's like a dial-up kind of connection where you're trying to establish connection to the server through a phone line. So that connection needs to happen. So you dial the number and then the IP address of that phone gets routed to talk to the IP address of that server. You know, So when they do connect, that's why you keep you keep hearing the tones that will beep like every time you're waiting. That's the connection trying to be established, right? They can try 1, 2, 3 times and the connection fails. You keep trying again until that connection establishes. Then you're gonna get the call in place. But that is dial-up is old technology that is kind of phased out, you know. So they've moved away from that and they have better means of communicating now, establishing communication. So you won't come across dial-up in any environment in your work life. I promise you that. It's legacy. So don't really worry about it.
No, I was just actually trying to understand based on what we're talking about with the network protocol. And I was just comparing it with how it used to be. To see, okay, if the dial-up happened because you didn't have a router, right?
No, it's going through some router somewhere. You know, there is always an
Okay.
ISP in every city, right? So even if you have a phone line at home, you have an ISP that's providing you that phone line, right? So it's gonna go through your router, even if you don't have a standing router at home, right? It's gonna go through your router. So for two networks to talk to each other, both routers need to be communicating. Like if my network needs to talk to your network, it is my router and your router that's going to route the traffic between our networks. So the routers should always be there. But for something like a phone call to occur, you need a certain protocol, which Charles just explained. You know, certain protocols that are behind doing a phone call, and a good example would be UDP. You know, if you're using the user datagram protocol, you know, it's mostly used for phone lines, phone communications, phone calls, things like that, because it is a faster protocol. But like I explained in some other class, it will not guarantee that the data will be transmitted. That's why I can talk to you in a phone line and the call keeps breaking. It means data packets are being dropped while we're communicating, right? But the call is not gonna end, right? We're still gonna talk. You hear some stuff. If the call is breaking, it means some packets are being dropped, right? But the call is still gonna keep on happening until we're done talking. So that's what UDP will do. But TCP is another protocol that works alongside UDP that it's a slower protocol, but TCP will guarantee that, okay, if I'm taking this data to deliver to this person, the data must be delivered. So TCP is reliable, but it's slower. And that's why we cannot use TCP to do a phone call. Because by the time I say, hello, Emeka, and you say, hello, it'll probably take like half an hour because TCP needs to guarantee that all the data that I'm sending to you is received. And TCP does something called a three-way handshake, which Charles is going to expatiate and talk to you about. And it's very important. So take note of this word, three-way handshake. Very common in interviews. So TCP does that, which it sends like an acknowledgement and then gets a seen acknowledgement and then acknowledges back before it starts transmitting data. That slows things down, you know. So UDP is faster and it's mostly used for communication like phone calls, video calls, things like that. I think our lines are kind of stable right now. So
thanks for talking. You when you talk
take over
to normal.
So we just had like a 10 minutes break, but what we did was still useful and we still learned some new stuff.
All right, guys. I'm going to go back to sharing my screen. Host disabled participant screen sharing. Jared, can you give me permission to share? Jared, you're muted. All right. Hope you guys can see my screen. Can you guys see my screen?
Yes.
All right, good. So the next thing we're going to talk about, so you guys understand the traceroute command and how it works and how we can use it? Was that clear enough?
For my Mac,
Yes.
I tried the tracer. I tried the trace route. It didn't work. When I tried the tracer, it actually worked.
So traceroute is for Linux machines. Traceroute is for Windows. So
Okay, got it.
Unix machines, you're going to be doing that in the beginning of April. You're going to be using commands like traceroute. So for Windows, it's traceroute. So that's why it did not work. And when I wrote traceroute, I would think about from Linux terms, not the Windows. So if I went here, let me see. So let's 253 58. I don't know which server this is. All right, I just want to give you guys an example of traceroute. All right. Traceroute to all right, I need to install that on my Unix machines. I won't do that because we don't have time for that right now. Let me see if I do have it installed in my Git bash. Traceroute to google.com. All right, I need to install that. So you guys can go and fire up Git bash. Let's leave alone traceroute. You guys will do it later. So let's move on to the next concept. We shall do traceroute when we get to the Linux bit of things. All right, guys, what's an IP address? In your own words. All right, let's start with Ola. Ola, what's an IP address? In your own words, how can you explain to us what an IP address is? Ola, are you there?
I am. I'm using two screens, so it takes a while for my mouse to get to the other side.
All right.
I think it's an IP address is a set of numbers that's assigned to every device on the network. You can use it to also communicate with the internet. I think
all right.
That's a brief one.
Yep, guys, that's it. It's just numeric address assigned to every device participating in a network or a computer network. And those numbers are used to communicate. So let me just give you an example. If I need to mail out something to you, maybe I need to mail out something to Gerard. I need to know Gerard's home address. That means I cannot just send I cannot just send the package with Gerard's name. The package should have his address. So let me say maybe he lives at 111 Linux Avenue, Houston, Texas, and his zip code. So when I go to the post office, I make sure that I send that package to 111 Linux Avenue. And that's how that package is going to get to his doorstep. So the same thing happens in computer networks. Every device has an internet protocol address or an IP address, which is a set of numeric numbers that's assigned to that device for that device to be identified in the network that it is in. So for instance, when we fired up our command prompt here, and then we did an IP config /all, we got details about our network. And one of those details that we got about our network was the IP address. So question is, let me ask Ebenezer, are you there? Ebenezer, are you there?
Yes, I'm here.
All right, I do have a question. Can two devices on the network on a network have the same IP address?
No,
Why not?
each device gets its own IP address.
Yes, why does each device get its own IP address? That's my question.
Oh, because you know, you need to send data from one place to another, and like sending messages from house to house. Every place has an address to get the message sent across.
All right. Can someone clarify on Ebenezer's point? Guys, we I know we're just learning the terminology, but during interviews, you're going to be on the spot. You're going to be in a seat because you're telling me you are worth 100,000. That means if you're telling me you're worth 100,000, I'm going to put you on the spot, and I'm going to make sure that you are the right hire. So when I call out your name, it's because we're starting right now to do the interview mock. I told you my experience where I failed more than 30 interviews, but those interviews prepared me. So guys, can someone else give it a shot? Maybe.
Yeah, let me try.
All right.
So there'll be what we call an IP conflict. So let's say, for instance, you are sending a message or a packet to a particular device, and when the message got there, there are two IP addresses. So that packet wouldn't know which device is supposed to deliver the message to.
Yep, amazing. Guys, there will be an IP conflict because two devices will have the same IP and the same network. So you're like, is this Gerard's package or is this Gerard's neighbor's package? So based on the same analogy, two devices cannot have the same IP, just like two people cannot have the same name and the same home address. Does that make sense, guys?
Yes.
All right. So I gave an example here. I just put it for you guys in a pic so that you guys can understand what I was talking about. So in the physical world, you have street addresses and you have house addresses. Can you guys mute if you're not talking or if you don't have any questions? So in the physical world, we do have street addresses and we do have house addresses. In the networking world, we do have network addresses and host addresses. So we're going to do a quick demo. Can you guys have your Windows, your machines up? I need you guys to access the control panel. We're going to go to where we can configure our IP addresses to be static. All right, first step is you go to your control in the search, type here to search. If you guys can see my screen where it says type here to search, can you guys see that? If you tell me yes, it will help me.
Yes, we can.
Move fast. So when you say control panel and say type, and then just say enter. Do you guys do that? Let me go back again. Say control panel right here. Control panel, this right here. Let me know when you get there. And then here, we're going to look for network and internet.
Charles, can you switch to small icons? So because their view is going to be different.
All right, let me see. Small icons?
Yeah, small icons, yeah. Sorry.
Right. You guys are here? If everyone is here, I can move on to the next.
There we are.
All right, so go to network and internet. Yours may be, some computers may be different. This is going to be a bit different for everyone. So after network and internet, go to network connections. If you get to here and you cannot see maybe network connections, just go to change adapter settings. That should be able to take you to the same place that I want us to go. All right, so when you get here, I need you to search for your network. It will give you different networks that you may be on, but I want you to search for your network that's up, the one that you're using right now, and then go to properties. Is everyone here?
No.
All right, where are you right now?
Network and internet. And when I click on it, I get to see connect to network, view network status and tags, view network computers and devices.
All right, so on your right, can you see things like change adapter settings to the left? Because this is going to be different forever. You say you're in network and sharing center?
Yeah, I'll click on it. Okay.
All right, so to the left,
yeah.
change adapter settings. So is everyone there right now?
Yeah, change adapter settings, yeah.
All right, Caesar, are you there? Ola, are you there?
Yes, sir.
Bismarck, are you there? Ebenezer, are you there?
Yes.
Change adapter settings. All right, guys, let's go to change adapter settings. And when you get here, you look for the network that you're connected on. So right now it shows I'm disconnected from this one here, not connected, disabled. It shows that my network is this right here. Ethernet 8 is my available network. Can you guys see it right here? So can you guys identify your available networks and right click on that network and then go to properties? Can someone say I if you're there already?
I.
All right. Those are two people. Faith, Ola, are you guys there? All right, good.
Yes.
Faith, where are you? Ola, where are you? Javis?
Yeah,
I'm there.
Okay, cool. So right here, we can see that networking. So we are given, we do have what we want to go into is the IPv4. You can see right here, TCP IP v4, Internet Protocol version 4. I think Jonathan had an issue. Jonathan, it's not an issue. So for Jonathan was resolving using IPv6. So Jonathan, if you're here, is your IPv4 checked? This right here.
Yes, please. Let me. Yeah, it's checked.
Checked. And IPv6 is also checked, right?
IPv. Yes, please.
All right. So you're using you are using both IPv4 and IPv6. So
yes,
guys,
please.
let's go ahead and click on IPv4 right here, Internet Protocol version 4. Just click on it once. And can you guys see where it says properties?
So I think Jonathan can uncheck the IPv6. So
yeah, Jonathan, you can do that.
Okay. Okay.
And after that, you can always go back and do the IP. Click once on the Internet Protocol version 4. And then let's say properties. You see where it says properties? Can everyone see here? I want us to be on the same page.
Yeah.
Yep.
Yes.
All right. Have you clicked on it? Does
Yes.
it bring you? Can you
Yes.
guys see this page that I'm on right now?
Yes.
Yes, please.
Yes.
All right. So here I have the option of obtain an IP address automatically or use the following IP address. So when I obtain an IP address automatically, I'm using the DHCP server to give me IP address to use to configure my network. So that means the IP address is being got automatically for me. The subnet mask is automatic. The default gateway is automatic. But when I say use this IP address or use the following IP address, that means I want to set up my own static IP address from the network. If that, does that make sense right now?
Can you come again, please?
So you guys have done DHCP, Dynamic Host Configuration Protocol.
Yes.
All right, what's DHCP?
It's a server that automatically assigns IP address to any host that log on to the network.
All right, I think let's go through that, and after that, we shall just leave the other page open. So,
Jonathan, I have a question. Is DHCP a protocol or a server?
No, DHCP is a protocol, and the
Okay.
protocol is installed in a server for you to get a DHCP server.
all right.
Yeah,
Guys-
you're trying to trick me.
Guys, listen, DHCP.
No, because he asked, what is DHCP? You said DHCP is a server.
Oh,
But
no,
DHCP
it's a
is not a
dynamic
server.
host configuration protocol.
Okay, good.
All right, guys, Dynamic Host Configuration Protocol. And that protocol defines how a DHCP server will assign addresses dynamically to devices on a network. You guys did your homeworks, right? Can I get a yes or no? So, you guys are quiet. Did you guys do your homeworks?
No, I think we have one more day before deadline to submit.
All right, cool. So when I say obtain an IP address automatically, I'm telling the DHCP server, which uses the DHCP protocol, to assign that address to my computer. It's like I don't want to configure the IP address by myself. I want my computer to be assigned an IP address by the DHCP server. But guess what? When we were resolving like google.com, when we did a ping of google.com, I know I'm introducing a lot of concepts, but I'll try to be as slow as I can. So what I'm going to try to address right now or to explain to you guys is the use of having a static IP address. I'm thinking if I should, okay. Let's leave this page alone right now. Let's talk about DNS. Guys, when we did a ping on facebook.com, it resolved to a particular IP address, right? Yes.
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 We saw that it resolved to a particular IP address.
Yes.
So,
Yeah.
all right, good. So that means that IP address has to remain the same. The next time, if I do facebook.com and this IP address has changed to a different IP address that is not pointing to the server which had that IP address before, that means I'll be pointed to a different resource, or I'll be pointed to an address, an IP that doesn't have the resources that I need. Does that make sense?
Yeah.
Yes.
Are you guys sure? All right. This is okay. Let me try to use another term or analogy. Let me say the market that I go to has an IP address of 111. That is the market that I go to maybe to get my favorite cereal. And to go to that market, I say market.com. And market.com points to 1111. That makes sense, right? So I want to make sure that 1111 does not move. It is static, it stays the same. So that is why that is what I'm trying to explain by here, by saying if I want to obtain an IP address automatically, that means if I set 1111 to be automatic, that means after a certain period, there's what we call a leasing period. The DHCP server leases out IP addresses for a particular period. Maybe, let me say, arbitrarily, it can be set to maybe 30 days. And after the 30 days, that server, that IP address can change to any other IP address. So going back to my previous example of going to the market, market.com has to take me to 1111 because 1111 is where I'm going to get my favorite cereal. But if the DHCP server all of a sudden dynamically allocates to a different IP address to market and points market.com to 1112, will I be able to find my favorite cereal at 1112? Can I get a response?
No.
No.
Why?
Because the address have changed.
Because the address has changed. Now market.com is pointing me to a different place. Market.com is not pointing me to the server, which is 1111, which had my favorite cereal. So that is why it's better to set a static IP. When I set a static IP, market.com is always going to point to 1111, which has my favorite cereal. So that 30 days from now, 1 year from now, 2 years from now, I'll be able to go back to market.com and find my cereal where I need to find it. In this case, it could be, now let's bring it to computer terms. Remember before we're talking about things like.
Senior Charles, sorry, one question, please.
Sure, fire away.
So the DHCP, you said it leases IP address.
Yes.
So when you configure the IP address to, like, let's say a static, you also have a lease period for that, or is permanent?
It's permanent. So static is the same as permanent. Guys, remember, I'm bringing you guys back to this example. We had a file server. This file server has an IP address. We have a database server. This database server has an IP address. We do have a web server. This web server has an IP address. So a file server, when someone queries a file server or asks for a request from a file server, the file server will return a certain file that this user needs. But if this file server's address today is 1111, and maybe 30 days later, it changes to 1112, if someone says, go to file.com, based on the DNS, file.com will be pointing to a different address, not the address that it was pointing to before. I know I'm introducing now, I'm introducing different concepts right now. I'm talking about DNS. We say DNS resolves a host name to an IP address. But at the same time, we're trying to set our IP address to be static. So I'm bringing together DHCP concepts and DNS concepts and combining those two concepts. So when you guys go back and study what DNS is and what DHCP is, you should be able to, one, understand the fundamentals, and also now you're going to learn how to bring these concepts together to solve a bigger issue. So for instance, now I need my clients to be able to go back to file server 10 years from now and be able to find those files at the same location where I have stored those files, or 1 year down the road. I don't want to be receiving a call 1 month later and saying, I'm trying to access fileserver.com and I cannot get the resources that I need. So how do we resolve that issue? How do we resolve the issue of someone not not finding the resources they want at a certain IP address. And that's why we bring in the concept of static IP address. So when I use a dynamic IP address, that means, yeah, sure.
So basically from the explanation, what I'm understanding is that there are some devices that should have static IP addresses. And then there's some devices that don't need, they can obtain IP address automatically.
Can you
like for example,
can you speak up a bit louder? I didn't hear what you said. Can you speak up a bit louder?
Okay. I think I talked about that last week, and I did say there are some devices that in a work environment, they need to have a static IP. And who can give me an example of one of such devices?
The servers.
Printer.
Exactly. Printers, servers, things like that. They should always have static IPs.
So devices have shared resources. Like if versus an Jared gave an example of a printer, we all use it will be different people using the printer, and you want that address to be static or to be the same because it's a shared resource. So for someone's laptop, that may not be as important, but for servers and for the devices that you guys talked about with Gerald, like for the printer, we need that to be static. But did that answer your question? Or did you have another addition to the question you had?
No, I was just want to get a clarification, that's all.
All right. So
Based on
guys,
what you were talking about.
all right, cool. So guys, we need to understand the fundamental concepts. So right now I've introduced the concept of DNS. I've introduced the concept of DHCP. And we have emphasized the point of why sometimes we have to set up a static or a permanent IP address. Do you guys, is this clear, or do you guys want me to go over it again? Because I'm going to ask one of you guys to explain to me what I've just talked about. So
Can you go back to your file? I'm sorry, the slide for the DNS.
Emeka, can you say that again? Can you speak a bit
Can you go
louder?
back to your slide, the DNS slide?
DNS slide, sure. But guys, I need you guys to understand the basics because from here we're going to be flying. DNS, this right here.
Yes, that one, yes.
Did you want me to explain this?
No, there's something I wanted to write down.
All right, guys. So talking about DNS. So we know that what DNS is, domain name system. And it converts names or domain names to IP addresses. So guys, when I go into my browser and say facebook.com, the DNS or the domain name system will resolve this right here. Will resolve the facebook.com to an IP address. Just like how we saw when we did a ping on facebook.com. Facebook.com is a language that we as humans understand. But for the computer or for the server to understand that language or what the request that we're trying to make for it to give us back, it is translated to an IP address. So computers and other devices on the internet don't really understand what Facebook.com means. But guess what? They do understand the numerical IP address that is assigned to them. So, and that's where we brought in the concept of DHCP2. And we said, we need that numerical address not to be changing. Because if you tell me today, I'm going to be living at, Jared is going to be living at 111 Linux Street. And then tomorrow he moves to 112 Linux Street. Packages are going to be made to 111 Linux Street and Jared won't be there. Or I'll come and make a request that Jared, can you give me ABC? Or can you give me some notes on Linux? And guess what? he won't be able, that address won't be able to give me those resources because those resources are not located at that address. And that's why it's always good to set up a static IP. So let's go ahead and set up static IPs on our machines. You can always undo this, but let's go ahead and set up static IPs on our machines. So can someone walk me through that? Let me see. Faith. No. We have two Faithies, right? Who is Jervis?
Me, yeah.
Jervis? All right. Can you walk me through how I can assign a static IP address? How do I even get to know what it is? I mean, where can I get an IP address to assign as static to my machine?
Go to your control panel.
No. That's a long way. We're already here. So we're already on the control panel. We reached. So where do I get that IP address to use here? Where do I get this ask? Where do I get the default get? Where do I get all the network configurations that I'm going to use to enter in here?
That is, I mean, it's you have two options to choose to either do it automatically or static. But if you choose,
okay, we're choosing static in this case.
Yeah.
We're choosing static. So where am I going to get the IP to use right here? Where can what's the simplest way to get this IP address?
From the command line.
All right, show us. Okay, okay, walk us through it. No, don't show us, but walk me through it. Okay, on the command line. What do I do on the command line when I get on the command line?
If I just open my command line and see.
Okay, let's just continue. At the command line, we'll type IP config/all.
Okay, good. All right.
From there, we'll see.
All right, Jervis is walking us through this. So everyone, let's do what Jervis is telling us to do. So
yeah, from the command line, we'll see IP. We'll give the command IP config/all.
Okay.
It's going to display the DNS. It will display the static, the dynamic IPv4 and all those stuff that we need. So now we'll go now to the whole section.
All right.
Of the IPv4 address.
Let me do what Davis is telling us to do right now so that I can learn from him. All right, guys, I did what Davis told me to do. So I went
Bismarck talking.
Oh, that's not Davis?
No, that is Bismarck.
Davis, what happened?
Yeah, I was.
His network was not connecting, sir. So we just continue. Now we'll go to.
Bismarck, you must be a salesperson.
So when we go to.
Okay, let me cut you. Okay, just a moment. Let me cut you short a bit, just a little bit. All right, I did an IPv config, IPv config/all. Guys, remember when we went right here, we chose this network. You see this network right here? You guys are seeing this network adapter? Yes?
Yeah, but in my own case, for instance, for some other people who don't have Ethernet adapter, some people have a Wi-Fi adapter, they'll go back to under Wi-Fi LAN.
Yes. So what I'm trying to, just a moment, what I'm trying to explain is, guys, when you come here, you need to choose the right network. So under network connections, I chose Ethernet 8. And this Ethernet 8 right here corresponds to the one that I'm choosing when I did an IP config/all. Because as a systems admin, you have to be meticulous. You want to be assigning a static IP address to a very different network. So you have to be meticulous in what you're doing. So let's go ahead.
Charles, just a second. Talking about that, what Charles just said, right, is very, very important. Like common sys and min mistakes. You have a server that is already configured and you go to configure a static IP and you go select the wrong network adapter. And you go take that IP and you wrongly configure it to some network adapter on a server that's already on the network. Big problem. You can get fired for that. So you need to be very careful when you're doing this.
All right, Bismarck, we cut you short. Please go ahead.
Okay, so right now
I have identified my IP address. So my question is, Is this a static IP address, or is it a dynamic one? The one that I have on my left side.
What you have on your left is dynamic, so we want to make it static.
All right. Can someone else? Does everyone agree with what Bismarck is saying? And are you guys following along? Are you guys, Emeka, are you following along?
Yes.
Are you sure? That was all right. So IPv4 address. So I'm going to get this. Bismarck, give me a moment. Wait, 192.168.253.62. All right, Emeka, what's the next step? What else should I do? What else do I need? Are you still there? Sorry.
Yes, sir. We need the subnet mask, mask for that particular network Ethernet adapter.
All right, guys, we need the subnet mask. So we're going to do the subnet mask later. So mine is 255.255.255.0. Later on, we're going to understand what that means. So when I clicked in here, it just auto-filled. Now we're going to understand why it even auto-filled later on. All right, what else do we need?
Gateway.
Guys, we need the default gateway. And what did we say the default gateway does? Guys, what did we say the default gateway does? What did we say the default gateway does?
So default gateway is the IP of the router. So it allows.
Jonathan, you answered that already.
Oh, okay. I'm sorry.
Javis. Let's go, Javis. What is the default gateway and what does it do?
It's the IP address of the router, and it allows inflow, like communication between your device and the internet.
All right, guys, that is where the packets or the information or the data flows into and out of your network. All right, Bismarck, sorry, I cut you short. So what else do I need, Bismarck?
Senior Charles, one quick question, please. I'm really sorry.
Sure.
I'm trying to get this IT terms right. Okay. What is the difference between packets and data? Are they the same?
Yes, it's the same. Packets, data, they can be interchangeably used.
Jonathan, you can even call them data packets.
Okay, thank you.
It's the same. Data packets is fine.
All right, Bismarck, walk us through this.
Yes, sir.
I want to ask a question, sorry.
Yes.
How do you know that you have the Ethernet adapter on your, when you do it on your CMD and then you do it on and you want to change your IP address to static, and how do you know it's an Ethernet adapter that you're using?
How do I know it's an Ethernet adapter? So,
because I don't have that because I'm using wireless. So.
Yes, now Ethernet, an adapter. Remember what we talked about in the network diagrams? You guys remember that? We said the NIC, you can access the NIC in two ways. It can either be wireless or you can have something plugged in. So for instance, right now I'm using my Ethernet. That's what I'm using to plug into my network. So that's why it's giving me Ethernet adapter, because I do have a USB in Ethernet, USB.
Sorry, you were breaking a bit, so I didn't get you. You were breaking a bit, so I didn't get you.
All right, I'm going to explain again. So what's an adapter? It's a device that I can plug into my computer. So the one that I'm plugged in right now is an Ethernet RJ45 to a USB-C. Remember in this example right here, I gave you guys an example of an Ethernet adapter. Let me see. Guys, right here. This is an RJ45 to USB-C. but I'm using a docking station. A docking station on this side has an RJ45, and on this side it has a USB-C. So that is my Ethernet adapter. So that's why when I go down to my network configurations, this and where's my command line? I've lost my command line. I've lost my command line. Let me see where that command line is. I have like 1,000 tabs open right now. Anyway, did I answer your question? So you're using wireless. That's why you don't have an adapter. You don't have a physical device plugged into your computer. But if you have a physical device plugged in, you're going to see adapter, like you have an adapter plugged in. And that is what is that's what your NIC is using to communicate. So right now you do have wireless. That's why it's giving you, that's why you're using this. If I unplug, I'll be using this instead of this right here. I'll be using the wireless LAN adapter. Yes.
So Faith, in a nutshell, Faith, because you are connected to the internet using Wi-Fi, your network adapter is going to show up as wireless LAN adapter.
Yeah.
If you were connected with a wired connection, it's going to show up as Ethernet adapter, like he's right now. So you want to find the adapter that, based on how you are connected to the network, that's where you configure your settings. Make sense now?
Okay, yeah.
All right, Bismarck.
Yes, sir.
Are you still on fire?
Yes, sir. We'll continue with the
all right.
The DNS configuration.
All right, DNS. Where do we get the DNS configurations from?
The DNS configuration.
Mm-hmm.
The DNS configuration should be on the same or below.
Guys, right here. So these are the servers that I'm using in my network as my DNS servers. But later on, we shall get to see that if you don't want to use your own, in regard to availability, you can also use Google. Do you guys know what the DNS servers for Google are? 8888 and 8844. So we shall do that another time. So I don't want to use my, let me say I don't want to use my DNS servers because I don't trust their reliability. How many times does Google go down? How many, have you guys ever?
Almost never.
Rarely.
Guys, never. So should I trust my own servers, DNS servers better, or Google? What would you guys choose if they asked you between Google and yourself? Which one would you trust better? Who's servers? All right, guys, I'm also trusting Google right now. Let me use for Google. I don't want to use mine. So I'm going to use Google's servers, DNS servers, for my resolution instead of using mine. So I'm going to use Google as the preferred DNS server. The other thing that you can do, you may say, I want to use Google just in case mine is down. So for the first line, for this first line right here, I say I want to use mine to resolve. So mine is 192.168.253.7. That's my DNS server. So I'm going to explain to you why I'm doing this. 253.7. So just in case my DNS server goes down for any reason, I have an alternate DNS server, which is Google's DNS server. So guys, let's go ahead. If you've been following along and doing the same, just press OK. So right here, before, let me see if it has changed from dynamic to.
No, I think you got to run the command again.
Yeah, okay. You see, guys, here it says DHCP enabled. You see, guys, you see that? It says DHCP enabled. If you guys cannot tell me yes, that means I cannot move on.
Yes, we see.
DHCP enabled.
Yes, sir.
So now we have configured static. So let's go back and run this command again and see what it will give us for this Ethernet adapter, Ethernet 8, if it tells us either DNS or static or permanent. So this is the line that we're looking for. And that means we should have verified that we do have a static IP address. So let me go ahead and run this again. So guys, remember it was Ethernet 8. So let's look for that particular adapter. Where is it? Let me first clear this screen. All right, let me look for my phone. All right, it still says DHCP enabled. Do you guys know why?
Yes. It's because we have not the static IP. We have not yet. We have to restart the system.
No, we don't have to restart the system. We have to save the changes.
We have to save the changes. I mean.
Okay. Let me see. All right, that should be able to do it. Close. Okay, let me run it again and see this time if it will give me the static. Where am I? Let me just bring this up again. IP. This is going to be I hope you guys are following along and doing this. Because right now, you should be having questions. Things should be failing and should be asking us how to resolve things or how to resolve. All right, guys, what do I have right now?
No.
DHCP enabled was yes before, but right now it says DHCP enabled, no. What does that mean?
It means that
static.
It means now we have a static IP address. So let me go, let's go back to the control panel. And let's go back to the network. Let me go back to my network adapter right here, properties, IPv4. Guys, I'm using this as my static IP. Any questions? We're going to stop here. Questions? Do you guys have any questions? I'll take that for a no. You guys can hear me, right?
Yes.
Okay.
I have a quick question. So on mine, when I ran it, it says my list was obtained today and it expires today. Is that a normal thing?
That is how your list is set up. Yes, it's normal for it to say it's expiring today. Yes, it's normal. So I think in what I need you guys to do for your homework, Gerard, I think they should be able to obtain, run a command to do a listing, to renew their list, to renew their IP address. I think we should put that in the homework folder for today.
Okay.
All right, guys, I need you guys to go ahead and walk through this last part. You need to be able to navigate around this area. I remember one time I had to go to the data center and I had to connect to a different network and I had to identify that network and I had to obtain an IP address and connect to systems in the data center using my laptop so that I can perform some activities and some other configurations that I had to perform from my laptop while I was connected to that network. So what we walked through today, just make sure you can go through that from start to finish. Make it static, and after that, go ahead and confirm that it's static. After that, go ahead and make it dynamic. Go back and see that here, dynamic enabled says yes. So that you guys can be able to navigate around your systems with ease and know what to configure and how to configure network static IP addresses. Gerard, do you have anything else to add to this?
If I have anything?
Yes, they didn't have any.
I think we are 2 minutes to closing, and I think we've had a wonderful session. So at this point, Charles, you can stop sharing. Let's just chat for the remaining 2 minutes, and then call it a day. Personally, I think we've had fun, and I enjoyed the session. I don't know about the other people in class, but it is my expectation that everyone is following and everyone is understanding what is going on, and we are all learning together. Am I right or I'm wrong? Any comments, anything to say? The class is open right now for any comments and reservations.
Guys, if I was too fast, let me know that I was too fast. And then next time, maybe I'll slow it a bit. If I mixed too many concepts at the same time, for instance, I was talking about DHCP, obtaining a static DHCP server, this address, and then after that, DNS resolving to a certain IP address. So if I was too fast, let me know, but also go ahead and watch the video again. And also the recordings that were recommended, plus your homework, that should give you a solid foundation. Guys, remember, this is just a foundation. Gerard, please.
Yeah. So the class is open for questions or comments or observations or recommendations.
Yeah, just to talk about what Charles said just before he rounded up his class. He said he had this time when he had to go to a database. So I was just thinking that when we're discussing this concept, it can be nice if you can, you just maybe at the end of the class, you can just give a practical situation where you have made use of what we have done, just so we start to get familiarized with how we can apply what we are studying. Because as you're taking it, it's nice to have a picture of what you're going to do with it.
Okay, so let me just give you an example of like what we just covered today, right? We talked about DNS, DHCP, default gateway, certain static and dynamic IPs, right? You could be in a situation at work where you have a server that was working well yesterday, and today people are not able to connect to that server. So based on the knowledge that you've had today, you should be able to take that knowledge and go troubleshoot that server and find out why that server is not connecting to the network based on all the troubleshooting skills that we've acquired. So you want to start by pinging that server. Is the ping responsive? Are you getting a positive or a negative ping? That is where you start. Based on your ping results, okay, is the server down or it's not down based on the ping result? Is it an IP conflict? Let me go check the adapter settings, things like that. So you face numerous networking issues within work, right? And every scenario will be different. But your understanding of these concepts should help you resolve those issues. Maybe the server doesn't have an IP address. Maybe someone disconnected it and it's now IP-less. Let me use that word if it even exists. So you should be able to go troubleshoot and check the adapters and know, okay, where is it resolving from? Things like that. Are we using an internal DNS server or you are using an external DNS server? If you're trying to set something internally, and then your DNS server is resolving to Google 8.8.8.8, do you think Google's DNS server will resolve something internally in your network? Who can answer that question? It's not going to do that, right? So you're going to know that, okay, whoever configured this DNS server and use Google 8.8.8.8 for internal resolving made an error, because there is no way Google server sitting on the internet will resolve something within your network. But if you want to resolve something externally, say Facebook.com or CNN.com, Google's DNS server will be able to resolve that because it's out there and what you're looking for is out of your network. So that's how you apply this knowledge. So there are several scenarios that we can come up with, but we're gonna do a lot of practical projects where I'll create scenarios. Charles will simulate things and send your way for you to figure it out. That's how you learn, because this is how the problems come up at work. You know, it's not like what we are teaching you here is what you will see. You can experience anything, but it's based on this knowledge and understanding the knowledge and using the knowledge to troubleshoot. That is key. Any other question?
No.
Okay. So guys, look at the homework. The homework covers a lot of the stuff that Charles is talking about today. And most of the stuff I have we've talked about in the past. So you will not see a lot of things that are new. One of the questions on the homework is to download an ISO image. So please, for that, you need to watch a YouTube video. Go to YouTube, find a video on how to download a Windows Server 2012 ISO image. Also, how to download a Windows Server 2016 ISO image. It might take you to the Microsoft website and they'll ask you to put some information. Don't worry, if they ask you to put name of company, put anything, you know, it's not a problem. Just put any, if they ask you name of company, your role in the company, just answer it. Don't worry about it. You don't need to put what you're doing. Just simulate any title and put in there. It's just a protocol for them to let you download that ISO image. Download the ISO. We're going to be using it to build up our Windows server. If you have any question, please Slack me. You need help, please Slack me. But I hope everyone has been able to download all the applications that I sent you. Mobile XTEM, Poly, WinSCP, TeamViewer, and all those other applications. All of us are all set with that, right? Is there anyone who's not done that, or you faced any problem? Okay, we're all set. All right, guys, then let's take a break today and call it a day. It's been a wonderful session, and I'll see you guys tomorrow. And the class is going to be up 1 hour from now. All right, guys. Thanks so much. Thanks for your time.
Thank you.
Thank you, guys.